Hi, good afternoon everyone. I'm Andy and I am from the Discharge Quality Branch of Water Reclamation Network Department in PUB. So my department's mission is to ensure that every drop of used water collected is fit for recycling. My role is to regulate and enforce wastewater discharge from industries termed as trade effluent to comply with the legislative requirements. So in today's sharing session, I will briefly share with you on the importance of my role and the current measure taken to ensure that trade effluent discharge from industries is fit for recycling. I will also share on the current challenge in taking discharge sample discreetly from certain type of sanitary connections and the requirement of the sewer robot that we are looking for. This slide shows our water loop. Water is scarce and precious resource in Singapore. New water being one of our 4 national taps allows us to reuse every drop of water. Hence, it plays an important role in water sustainability for Singapore. We have placed a risk-based multi-pronged approach to manage trade effluent discharge from industries to safeguard downstream treatment process as well as health and safety of our maintenance workers. In today's sharing session, I will only briefly touch on this. Factories are required to comply to trade effluent discharge requirements as discharge containing prohibited substances or excessive concentration of regulated substances affects the health and safety of our maintenance worker, as well as the disruption to the downstream treatment processes at our water reclamation plant and new water factory. Currently, for factories with higher risk of discharging prohibited substances or excessive concentration of regulated substances, such as those in the electroplating and chemical manufacturing industries, PUB will require them to install water quality monitoring instrument in their last inspection chambers. PUB officers also inspects these factories frequently to ensure for compliance. During this inspection, trade effluent samples may be collected for lab analysis and enforcement action may be taken if non-compliance is detected. Special operations are sometimes conducted in factories suspected of carrying out illegal discharge activities. During such operations, PUB monitors the trade effluent from the manholes outside these factories. PUB has an existing robotic crawler to deploy at public manholes to monitor suspected factories with sanitary drain line connected to the public sewer system via top-saddle type connections. The crawler comes with a small collection tank with covers to contain the effluent sample. The operator will maneuver it under the sanitary connection of the suspected premises to collect the effluent samples. For other type of lateral sanitary connections, where trade effluent enters the main sewer in other directions, the current robotic crawler is unable to collect a representative effluent sample as its collection tanks are designed to only collect effluent that is flowing vertically down. This slide shows the different type of sanitary connections. Straight and tumble bay type sanitary connections connects to the main sewer at 3 and 9 o'clock directions. That means either from the left or the right direction. So the existing crawler is unable to collect samples from these connections due to the design of its collection tanks. Backdrop type sanitary connection is similar to the straight type connection at 3 or 9 o'clock direction. As for Y junction sanitary connection, it is angled at a 45-degree angle, so therefore the existing robotic crawler is unable to collect representative effluent samples. The existing crawler can collect samples from saddle and raised connections where effluent is flowing from vertically down. We hope to find a robotic system that are deployed in sewers to monitor and collect trade effluent discharge from the various types of sanitary connections. The robotic system shall be deployed without the need for man entry into sewers and be able to remotely controlled by the operators from the ground. It should also be able to maneuver in different sewer environments and conditions such as negotiating bends in the sewer pipes and soft sediments. It should also carry cameras to visually inspect the sewage pipe, sanitary connection, and sample collection process. It should also carry a gas meter to monitor for hazardous gas at a source. The operational requirement of the robotic crawler shall have a suitable traction to maneuver in sewers with water level up to half bore and pipe invert filled with soft sediments. Record and display distance transverse with an onboard odometer. Cameras to observe visually and record evidence. Measure hazardous gas at source such as volatile organic compound, hydrogen sulfide, carbon monoxide, oxygen, and lower explosive limit. It should also have sufficient cable length and a minimization of drag. For the sampling mechanism, we are looking for a suitable actuator arm that can collect effluent samples from all types of lateral sanitary connections that we have earlier went through. The sample collected has to be representative of the discharge. That means it cannot be contaminated from other waste streams that are present in the public sewer, and bottles are kept after collection. The sampling mechanism should be equipped with 250 ml containers to contain the effluent samples with material that are compatible with the discharge effluent and designed to collect up to 5 discrete samples remotely. It should also preferable to have suitable electronics and sensing technologies for automation of tasks requiring human intervention. The robot should be designed for sewers with diameters ranging from 300 to 600 mm and manhole depth of up to 10 meter. Do take note that the standard sewage manhole in Singapore is 600 by 600 mm opening to fit the robot through. Other design requirements for robot to function in hazardous environment has to comply with relevant standards. We expect the customized robotic system could allow operators to monitor and collect samples of effluent discharge from various types of sanitary connections serving suspected factories without the need for man entry into sewers. If the pilot is successful, we are looking at a service model where the equipment is owned, operated, and maintained by the company. This brings the end of my presentation. So I hope to have received your proposal soon. Thank you. Bye.